Welcome to this presentation. This presentation will cover the commercial digital modes. We always get the question on why one mode is any better than the other. Really, they're all about even, and we'll get into the details on how they vary and the differences a little bit later. This presentation will cover P25, the NXDN mode, and DMR. Okay, first off, I'll reiterate that again. There are three main commercial digital modes. You have P25, DMR, and NXDN. All these digital modes use the same proprietary AMBI plus 2 vocoder chip. So all radios that are digital, P25, DMR, and NXDN, use the same chip in the radio. It's just variations in the manufacturing process after the manufacturers get these chips that makes it a different type of digital mode. Alright, P25 Phase 2, NXDN, and DMR are the three main competing technologies with 6.25 kilohertz bandwidth. DMR and P25 Phase 2 are two-slot TDMA in a 12.5 kilohertz channel. So they have two slots for carrying traffic in 12.5 kilohertz. They take the current narrowband channel and expand its capacity times 2. NXDN uses 6.25 kilohertz channels with a frequency deviation, with one channel per 6.25 kilohertz. And obviously we'll go over some slides later comparing TDMA and FDMA, show you some diagrams which will greatly improve your understanding of TDMA versus FDMA. Alright, P25. P25 is one of the older digital modes. It came around as Project 25, P25, also known as APCO 25. It came about in 1988. The FCC, at the direction of the U.S. Congress, began inquiry of users and manufacturers to improve communication systems. It was released in October of 1989 as a result of a coalition between APCO, National Association of State Telecommunications Directors, National Telecommunications and Information Administration, National Communications System, the National Security Agency, and the Department of Defense. The current users include federal, state, and local agencies, as well as businesses. Locally in our area, southeastern Illinois, obviously we've got the Illinois Starcom 21 system. Starcom is a P25 system. So obviously on Starcom you've got Ameren, you've got all the state agencies as well as some local and county agencies in the area. Richland County Sheriff's Department in Olney, they have a P25 system. Olney Police Department has a P25 system. Crawford County, Illinois is reported to have a P25 system. And the Army Corps of Engineers is a common user of P25 over at Carlisle Lake. This is a map of the Starcom sites and state police districts. You will notice the red lines are the state police districts. Dots are the 800 megahertz systems, and then the ones that have like a little yellow dots are actually the 700 megahertz sites, and then the ones that have the orangish yellow color around them are P25 Phase 2 sites. So those are the newer sites. Not all those sites are going to be Phase 2 anytime soon, from what I understand, because of the cost of upgrades. The next mode we're going to cover is DMR, Digital Mobile Radio. It's an open, defined by the European Telecommunication Standards Institute, standard TS 102361, parts 1 through 4, and used in products worldwide. DMR is not so much proprietary. It's format which many manufacturers do use. I know there are Hytera and Motorola and RCA, just to name a few of the manufacturers. It is designed with three tiers. DMR tiers 1 and 2 are conventional, and first were released in 2005, while Tier 3 was released in 2012, which Tier 3 allows for trunking. The primary goal of DMR was to provide a low complexity, low cost system that was interoperable between all brands, so purchasers were not locked into proprietary solutions. The reason I underline proprietary solutions on this slide is that did not work. Many of the vendors actually started producing their own radios, which were not compatible with others. Motorola Turbo, Hytera, Tate, Vertex, Kenwood, ICOM. Those are some of the examples of manufacturers that all have DMR radios. They should, by the standard, be interoperable, but Motorola has its own standard for its encryption. Hytera has an encryption that's even stronger than Motorola, and they don't communicate well together. Current DMR users that I was able to find, obviously the Florida Police Department, Clay County Ambulance. I also found that the Shelby County Area Ambulance Service is using DMR. That's according to online licensing. I'm not sure if that's correct or updated or not. All right. The next, we're going to cover NXDN. NXDN was a joint development between ICOM Incorporated and Kenwood Corporation that began in 2003, and NXDN was announced in 2005, with the first products hitting the market in 2006. NXDN is implemented as IDIS, ICOM Digital Advanced System by ICOM, and NextEdge by Kenwood. Its intended use was for private land mobile radio, PLMR, and low-end public safety. NXDN has also been selected by the Association of American Railroads to be their next migration from narrowband to digital. So those radios are starting to show up, and registrations starting to show up on the FCC database. Locally, the following users are on NXDN. Fairfield Police Department only has a school district that is using it for their buses. Salem Fire Department is using NXDN for their mobile extenders, and Murphy Trucking in Fairfield also has NXDN. Here's the comparison of TDMA versus FDMA. The basic difference is how the channel is used. With TDMA, time division, multiple access, the 12.5 kilohertz bandwidth is maintained. Thus, you're still transmitting over 12.5 kilohertz bandwidth, but the spectrum consists of two 6.25 kilohertz voice channels. So two channels inside one 12.5 kilohertz path. That's your P25 and your DMR. Now your NXDN is frequency division multiple access, and in FDMA, the particular bandwidth, which in this case is 6.25, at a particular frequency, let's say 150 megahertz, is used to define the channel, the same way channels have been defined in analog. The bandwidth is half that of a typical narrowband signal. Here's a little bit better of a drawing. Okay, this says on top, the two users share the 12.5 kilohertz bandwidth utilizing two channels. FDMA is on the bottom. The single TDMA channel employs two time slots per frame per user. So you're seeing the NXDN on the top. We've got 12.5 kilohertz. Here's a 6.25 channel 1, and here's a channel 2 on the same amount of channel. And then here, down here at the bottom, is your TDMA, your time division. So you got voice call 1 going on time slot 1, taking up 12.5 kilohertz. And here is voice call 2 in time slot 2, taking up the same 12.5 kilohertz. So to the average user, it doesn't matter. It's not that big a deal. One channel versus two channel, one slot versus two slots. It gets beneficial when you are able to stack multiple agencies in public safety, at least in the same bandwidth that you're You can get two agencies in the same bandwidth, same frequency that you are licensed for, whereas here you're only using the same bandwidth, but you're only getting one slot. You're taking one slot. It's a wider bandwidth signal. Hope that didn't confuse anybody. All right, and I want to thank you for joining us. I'm open to questions. I'm not an expert, and most of this was done by research. Here are my references. I did read this article, A Fine Line, by J.M. Jacobs-Meyer, P.E., and Urgent Communications. I got a link there. And key differences between TDMA and FDMA. There's a blog that ICOM had from back in 2014 that I used. So I want to thank you again for joining us, and hopefully you learned something